So far, we've reviewed the idea of angles and introduced this measure called radians. Then we saw how angles are used to determine points on the unit circle. In this section now, we'll introduce right triangles and how they interact with the unit circle. Then we'll use this relationship to define trig functions. Let's first see how triangles and circles are related to each other by looking at a picture. Suppose we're looking at the xy plane, and on the xy plane we have a circle whose center is the origin, and radius is any real number that's greater than 0. For convenience, we'll also call a point on the circle a terminal point with xy value just xy. And let's go ahead and call the angle between the point P and the point 10 theta. Now we can project the point P onto the x-axis and we can form a right triangle from this. The point that lies on the x-axis will be given by x0. From the sketch, what we can determine is the following observation. Given any point on a circle, we can determine a right triangle associated to that. And since points on the circle are determined by angles, we can associate to each angle a certain ratio that's associated with that terminal point. And this is going to be how we define trig functions. So let me go ahead and write down a few things that I just said. And let's review these steps, because these steps are the most important part of this section/chapter. Again, angles determine points on a circle. And points on circles determine right triangles. Further, ratio of sides of right triangles are going to be invariant under certain conditions, and this is how we're going to determine trig functions. More or less, for each angle, theta, we're going to associate a certain ratio of a right triangle. We'll now define trig functions and then summarize this section. Before we write down the definition of trig functions, let me go ahead and redraw the picture of our circle and a right triangle. So here's our circle, whose center is the origin. Radius is any number you want that's larger than 0. And inside, we have a right triangle determined by the point P that lies on the circle. This angle here is called theta. Then let me go ahead and label sides. Again, we'll call this side R, we'll call this side Y, and we'll call this side X. We'll also call Y equivalently the opposite of theta, which I'll just label as opposite. We'll label the side that lies next to the angle theta adjacent. And the side R we'll also call the hypotenuse. Then we define the trig functions as follows. Sine theta is going to be equal to the opposite side divided by the hypotenuse, which is going to be equal to y divided by r. Cosine theta is going to be equal to adjacent divided by hypotenuse, which is equal to x divided by r. Then tan theta is going to be equal to opposite side divided by adjacent side, which is the same thing as y divided by x. Then we can also define the reciprocal trig functions. This is going to be cosecant, secant, and cotangent. Cosecant theta is going to be equal to hypotenuse divided by the opposite side, which is equal to r divided by y. Secant theta is going to be equal to hypotenuse divided by the adjacent side, which is going to be equal to r divided by x. Then finally, cotangent is going to be equal to adjacent divided by opposite, which is equal to x divided by y. A thing to note is that these relationships on the right-hand side of our functions are defined for a circle with any radius, which means that the numbers on the right-hand side are a ratio that scale to any specific circle you want. They'll always be the same value. So whether your circle has radius 10 or radius 100, these trig functions will always have the same number. The only thing that determines what number you get on the right-hand side is the angle that you put into the trig function. And so generally for convenience, we work with the unit circle, since r will just be equal to 1 then. So in this section, we have defined the trig functions, but we'll really be focusing on right triangle components of trig functions, which means we're really focusing on evaluating trig functions for angles that form right triangles. And we're going to break this section into 3 different parts. In part A, we'll be looking at the trig ratio, which we've seen already a little bit of. Part B, we'll be looking at special right triangles. And these are triangles that appear pretty frequently in trig and other applications. And then finally in the last section, we'll go over an application problem.